me welcome you to the 47th lecture of NPTEL online certification course Drilling and Blasting Technology. This lecture title is Impact of Rock and Rock Mass Conditions. This is the second lecture of this impact of rock and rock mass conditions on blasting. As we do every class, we retrospect our previous lectures. So far we have discussed the understanding of rock and rock mass to be excavated by using drilling and blasting. The impact of rock properties are on the drilling is also discussed, as the drillability etc. discussed. The different drilling techniques, that is the percussive rotary drilling techniques, explosives and blasting techniques for surface and underground mines, those are discussed. We have also discussed the how to assess the blasting results in terms of fragmentation, fly rock, muck profile, ground vibration, powder factors. We have already practiced some tutorials related to the performance analysis and related to the designing of the blast, related to the cost analysis of the blast. In the last class, we have discussed about the impact of rock and rock mass properties on blasting, and we have seen how if the different benches are formed with the different layers, how that is impacting the design, and to cater those problems, how to spatial distribution of explosive has to be carried out. And we have seen the deck charging has to be practiced, how those decking will be placed for different rock mass conditions we have understood. So, continuing with that, in the last class also we have found that narrow occurrence of narrow veins in the or narrow zones, whether it is weak or hard, and that is in the bench layer. To cater that, either we have to provide a stemming part at this position, or if it is a very strong rock, we have to provide a high energy explosive in that particular conditions. Especially in coal mines, overburden etc., where we are having there is a special formation called jhama. If that jhama is very strong, very difficult for drilling and very difficult for blasting also. So, if that jhama layer etc. is coming in between a sandstone rock layer or etc., so that is very difficult to blast at this position. In those cases, high VOD explosives are often used to break that particular layer. So, that is very difficult condition. So, layers are very important in the rock blasting, and one must be very careful while the different layers are there. So, that is why it is always wanted that whenever the blasting has to be carried out in a bench, a person must stand, that blast designer must stand in front of the bench and look the bench formation from the front side to assess how the layers are there, how the joint sets are working, that must be assessed. So, the mapping of the face prior to the blast is very, very important. So, that is the essential requirement. So, continuing with that, let us discuss in this lecture how the joint and shear planes, fault planes, if they are existing in a bench, not horizontally, but in an angle across the bench, then how to carry out that one. So, this is one case where you can see the fault planes or shear planes are across the bench face. So, that is basically dividing the bench in a different formation. So, what is happening in this case? Basically, this act as a reflecting medium. This act as a reflecting medium for the blasting waves. So, as this is acting as the discontinuity reflecting medium, blasting energy will not transfer from this place to this place, So, by blasting of this one, the effect of this explosive will limited up to this distance only, it will not cross this one. So, what is happening? We must be very careful of placing our holes in the either side of this plane. So, suppose in this particular condition, if we are placing, for this case you can see the fault plane, around this our holes are almost symmetrically distributed. So, that means the fault plane is almost at the half spacing distance from the holes, but in this case this fault plane is very close to this one rather than this one. So, what will happen if this effect of this hole is limited up to this, then this portion which is supposed to be blasted by this one will not be achieved, because the explosive energy will be reflected back from this and the effect of the explosive on this zone will not be there. So, this zone, there will be a particular zone, this zone will not find it is properly broken, and that may create problem of movement of the burden. So, that is a very difficult condition, and one must be very careful when this type of situation occurs in the mine, and it is better that one must go for carrying out blasting in the either way. This can be considered as a separate bench, this can be considered as a separate bench. You may continue with having the initiation system across the shear plane, that is not the problem, initiation system is not the problem, but proper delay must be considered in this case. But that is not the problem, but positioning of the hole across the shear zone is very important, and one must be very careful in this. Okay. So, this is the condition when the shear plane is across or oblique to the bench face. In those case, this much care has to be considered while the designing is carried out. Generally, if it is parallel to the face, this condition is basically unwanted, not only from the bench blasting it is not that much difficult condition, but this is very difficult condition for the slope stability point of view, because here the slope, this slope may not be stable and this may slide down any time from this fault plane. So, from this stability point of view, this is very dangerous situation, one must be very careful about this, but otherwise if the blasting has to be carried out, again one has to consider that this portion, if it is blasted, if this portion is blasted, this will be the effect, and here the burden is the limited one. So, there is a problem that this portion may stand up as a standing wall, which may act a problematic situation for this one, this portion will not be blasted. So, it is better that we have to consider this situation where this portion, the effect will be considered, this portion will be blasted. Now, this portion will act as the free face for the next hole. So, that will be a beneficial situation, but slope stability, dangerous from slope stability point of view, must be considered for this type of situation, is a very required one, very important one, one must be very careful in this particular case. So, this is basically the considerations of the shear zone or fault planes when the bench blasting we are considering. There are other sets of joints occurs. If the free face is at this place, we may have joint plane just in the opposite direction of the free face. So, in that case, this is the blasting with the strike against deep condition. In this case, we can achieve a very good control over the back break, but the power requirement explosive requirement is little bit higher, because we have to force the rock against its natural free falling direction, that is the natural joint direction, we have to blast it against that. So, this is the blast against drip. So, that is why the explosive charge requirement may be more in that case. However, the control over the back brake or the post blast wall is very stable in this condition. But for this case, it is blasting is with the strike towards dip. So, that is why the face is towards the dip of the joint dip direction. So, it is very easy to blast condition. This is very easy to blast condition. So, with a little bit energy, explosive energy, this blast will fall, but there is a likely chances that our slope will take the natural angle of the joint plane. So, that is the problem, and if it is a little bit high, this portion of rock may be not stable enough, but here the explosive requirement is less, and that is a beneficial for the blasting with the strike towards dip direction, that is very easy condition for the blasting. If the bench face strike is with the dip towards the dip direction, that is very easy condition for blasting, and explosive requirement is less for that. Now, this is one case. The reverse case may occurs when we are having a free face. We are having a free face across the strike direction of the joint. This is the free face, these are the natural joint directions, this is the dip of the joints, and free face is at this side. So, in this case we are having a little bit different situation. So, what is happening, if we are carrying out blasting, the blast waves basically disrupt these joint planes. So, what will happen, we can see along the joint planes a long cracks, the blasted rocks is generates a long crack in the back side. So, in this case very high back brake may be observed after the blasting. Okay. So, that is a different condition, and that may create problem while we carry out the drilling in the next phase, that may create the problem at that time. So, that is why that has to be considered while the blasting is carried out with a when the blast free face is in the across the strike direction of the joint planes. So, in that case we must be very careful, and the possibilities of having larger back brake may occur in that case. So, now let us look once again how the blasting is carried out in the underground mines, because it is expected that long back we have covered the underground blasting part. So, this is that we provide the reamer holes, the 4 reamer holes are provided, centrally located blast hole is given, and this is a burn cut blasting where 4 reamer holes in the square cut pattern, 4 reamer holes are given. This is considered as Gurit charge or pipe charge, you can say. So, this is the explosive charge and this is the cartridge explosive. Okay. So, cartridge explosive. So, pipe charge generally we provide one booster charge, then the pipe charge is given. Pipe charge is very important one for blasting operation in the mines. Okay. So, what happened in blasting, the waves are propagated, it is fractured, and then it allows the material to fall down. So, this is more or less about underground blasting. I hope there are many videos available. This is the YouTube in YouTube. So, there are many videos of surface and underground blasting is available in YouTube. In fact, I would like to encourage the participant to look those videos, because that will give you a good understanding about the blasting operations. Now, suppose if we are carrying out blasting in underground and that is having joint sets parallel to the driving direction. So, in this case this is our driving direction. So, we are driving in these directions and these joint sets are parallel to our driving direction. So, if this is the case, in this case we have to carry out blasting, then it is a very favorable condition to achieve a best blasting results. The reason, let us draw it once again. Say this is our so this is our face and we are having discontinuity plane So, already the discontinuity planes are existing in this direction. So, now what is happening? The moment carry out drilling, what will happen is this drilling is allowed to excavation of the rock from this plane, and that is why after the blasting we will easily get a good advance, will easily get a good advance up to this distance. So, basically what happened, this joint strike direction parallel to the perpendicular to the tunneling direction. So, this tunneling direction and this is the strike direction of the joint. So, if that is parallel to the bench face, then what will happen? We may get 100% advance, even often we may get greater than 100% advance also by this blasting. So, this is a very beneficial for our point of view, where we will get the best advance while carrying out the blasting in the underground, because that will give us the better production rate, as well as we are having also very faster development. But that may create some cracks, along with the joint plane in the roof, and that may increase the support cost little bit. Okay. So, this is the problem, but obviously achieving 100% advance or greater than 100% advance is a very good benefit for having this type of system. So, this is very important one, and generally we love to have this type of condition. If we found in our naturally we are getting this one, but this is a very rare case, often we cannot have it. We can have the situation where this is, we are having joint sets parallel to the driving directions. So, that means this is the driving direction, we are having joint sets parallel to this. So, in this case again we can see and we are having joint directions like this. So, what is happening? The moment we carry out our drilling at this position, after blasting what will happen? After blasting, say we have achieved a new face of this one. Okay. Now, but the explosive of this one will create some cracks along this, So, that will basically creating problem while we are standing here and try to drill for the next hole. In that case, if we try to drill for the next hole, this cracks creates problem. So, that is the difficulty we are basically facing at this position. Otherwise, this is not that much hampering, we can get our desired pool, not 100%, but around 90% pool may be achieved, but creating the problem in the next drilling phase is very difficult condition in this particular case. So, this is the problem. Risk of higher roof overbreak is also there, poor advance per round predicted with joint striking the parallel to drive conditions. Now, we may have a oblique to the tunnel direction, that is the possibilities. If this is the tunnel direction, then this is oblique to that. So, in those case there are some difficulties. So, what is happening in this case? This is considered the plan view. Okay. So, the person is standing here like this and our joint sets are like this. So, this is the plan view, from the top we are looking at this. So, this is, that is why this person, and what is happening here, as the joint sets are like this, whenever we have carried out blasting here, so what will happen after the blasting, the free face will form a direction like this. So, this portion, the overbreak of this portion will occur, this portion will not obtain the desired break. So, the next phase we will find out the tunnel is now not now the parallel one. Now, this is the free face to us. So, this is the free face to us. So, the tunnel is just oblique one, and that is little bit problematic in the conditions. One has to always has that angular face, and controlling of drilling in the angular face is becoming difficult. So, right side wall is more prone to breakage with the joint set angle, and that is why wall control is little bit very difficult condition here. So, that oblique joints oblique to the drive or tunnel direction is a difficult condition in the underground blasting. So, that one has to take care of that one. So, that is a problem in this case. Now, that is why whenever the underground basically blasting is required, face mapping is basically one essential part, where we have to see the location of the joint sets, how those are there. In fact, this is in mining, it is not that much popular, but in tunneling sector the joint mapping is mandatory. In all the time the face joint mapping is carried out, though their basic purpose of face mapping is basically to evaluate the rock mass rating. Based on that, the tunneling rate is basically decided. Basically because of that, they have carried out the face mapping, but face mapping is very important one, and I would like to draw your attention in this particular case that face mapping, how it is carried out. So, basically face mapping is the person has to look into stand in front of the, a person has to stand in front of the face, look at the face and see what is the joint sets are there, how many joint sets are there, how the joints are basically angling, and that is basically mapped here. So, here the joint dips and joint directions are monitored using the Brunton compass or clinometer, and the number of joint sets are basically found, and those are mentioned as J 1, J 2, J 3 like that, joint 1, joint 2, joint 3, and the most prominent one basically named as the J 1. So, in this particular case you can see there are one joint sets in this direction, another is in this directions, another is this directions. So, locally there are many joint sets one can see. So, that has to be mapped properly and that has to be take care during the phase mapping. So, these are the two sets of joints are mentioned, J 1 which is having a J 1 is the main joint set which is having a dip, first one is the dip orientation. So, this is 80 degree from north, 80 degree from north is the dip orientation and it is inclined is 122 degree is the angle. I think sorry 80 degree is the 80 degree is the dip direction, dip orientation, and this dip dip direction is 122 degree from the north. So, this is 122 degree from the north is the dip direction, where J 2 is 58 degree incline and 175 degree, that is 175 degree, that is towards like this orientation is also found. So, these are the joint sets, how these are basically explained in the two sets of joints are present it is as, and these joint conditions are also mentioned here. Generally the geologist usually keep this record and they put it in the, but this is very much useful for the blasting people. We will come to that at a later stage. This is a real life picture where the joint sets are superimposed on this. So, these are named are given, this is taken from the website, and GPS is basically the sandstone, A is the clay shell, C is the coal. So, these are basically marked and boundaries are marked, joint sets are marked and on the face photo the map face map can be superimposed on the same. So, this is a very good example of monitoring the face, mapping the face for the joints. There are two instruments very commonly used for face mapping, one is the Brunton compass, another is the clinometer. So, basically both are this is fitted with a magnetic compass which gives the direction of the dip, and this plane part, and in this case this plane part, these two are basically utilized for finding the dip amount. So, if this is placed, this one is allowed to free fall and that gives the angle of the dip angle is basically obtained from this. Same thing is there also, this is the same way it is carried out. So, using these two the face mapping is basically carried out. This is a small video how the face mapping is carried out by this person. See, these are the different joint planes, the face mapping is from the in the site itself, the face mapping is basically made orienting its own face towards the face direction, and then all the discontinuities are being mapped on this. Okay. So, first these discontinuities are mapped on the plane and then it is first mapped like this, this is mapped, then these angles then these angles are, after mapping this one, these angles are basically measured using the Brunton compass. So, this is the positions are basically marked like this. Okay. So, this video is also available in the YouTube. So, let us stop this lecture at this position. We will continue with the use of rock mass classification system and use of rock properties on determining the or correlating that with the powder factor or blasting properties in the next class. Thank you.